Hello, it's Friday the 5th of July 2024 and I'm just doing a little video on Langton's Ant. Here we are, we have 474 iterations of Langton's Ant and the area is 3,600, so it's the small lattice. And here is the occupancy. So this is what's known as the binary lattice and this is what's known as the occupancy lattice because it's a grayscale. So here you can see that even though that's a black square surrounded by a white square, it is actually quite it's being visited many times, so it's very bright because it's quite high up. And here are the four lobes that aren't so high, and we can see that in a 3D representation. Here is that peak which is in the center, and then obviously this area here has had 0 visits, hence all this has 0 visits. And these are the ones that actually contain certain iterations, and the brighter the colour or the change in colour shows you how many there are. So you can see this green area here is this green turquoise area around here, so it's half the height. This blue area, the dark blue area on the lobes is all this down here, and obviously the red and the centre with the yellow is all of this up here, which is quite high. And we can see that in this form here as a linear plot. So to understand how this shape looks like this, you have to remember that this is a solenoid surface, and I'll show you that in a minute. But before we go on, let's remove, so obviously these are the dots now which are on the specific points in this lattice. We're going to stretch that out, and what we're going to do is we are going to remove the spaces, and we'll do that one at a time so that you can see it happening. Okay, here we go. So this obviously was the entire lattice from beginning to end, 65536 samples for the normal size. On this one it's only 3,600. And here you can see that the gaps, this is the ground plane, this is the area of 0 visits, is being removed. We're only interested in something that's actually got visits in it. And eventually this plot will drop down by 1 to say that there are no longer any zeros in there at all. There we go. So now the minimum is 1. Obviously it's showing 0 here because that's the end of the plot, and Octave does that. So now we will move on, and we will so what we've done now is we're going to take all of these values and we're going to order them from highest to lowest. We're just going to shuffle them around so that the highest is on the far left, and then they become minimum and minimum until they drop down to the bottom. And what you'll find is you get this plot. And this is quite an important plot because what it means is that this point here there's only one of these, but you can see that just here there's kind of like possibly 2, maybe. So you now see these red dots. And as we work all our way down, we see there's quite a few of these. They all have the value of about 4, I think it shows. Is it 4? Yeah, about 4. And there's quite a few of those. And these are these green ones. There's quite a few of those. And if you count up the pixels, you will find that there are, what have you got here, sort of 10, 20. So from about here to here, there's about 20 in the number. And you'll find there's about 20 pixels within that. Okay. That plot, if you now turn it on its side, is this plot. This was the one, and this is the one with about 20 plots of about height 4. And this is exactly what this is. And if you've seen this video, you'll understand that this is the occupancy counter for this, which is driven by the binary lattice on here. And this is Langton's Ant unfolding, and this is the spectral content, as I call it. So how does it work and how does it plot? Well, psi is a one-dimensional vector, and it holds in here it's showing only 60, but actually what this is it's 60 loops of 60 elements, giving you 3,600 area. Here we go. And what we're going to do is we're going to use this as a topological surface. Think in terms of an electronic choke or coil, where you have one end of the wire here and one end of the wire here, and what we're going to do is we're going to project Langton's ant onto that, and there she is. So you can see here's the line, and you've got the curve. That is this. Okay, and what that means is that if you want to index from 0 to 3600, somewhere along there you will find values of 0, but in here we've got -1 and +1, or whichever way you want to interpret. It's entirely up to you. So the values of 0, because there's nothing there, or the values of 1 and -1, or whichever way you want to look at it. That's this binary lattice here. This is important because in the tri-state Langton's ant, we are using the Fibonacci series to give us 0, -1 and +1 as an output, which is your fractional states. So what we're going to do now with this coil is we're going to join this end to this end to make a torus. And there it is. Now that is the two ends joined together, which means that if you had 65536 elements, which is 256 loops of 256 elements each, then the modulo 65536 keeps this as a continuum. There's no going around it. Now we can see how that maps on there. It's a bit disjointed because you're trying to do a projection, which doesn't really work. You have to remember, at the lattice size of the Planck's scale, then this would appear flat. So now we're going to up the resolution. We're now going to go to a much bigger lattice, which is 128 by 128. We do the same for the occupancy. We now increase the resolution of the winding, so this wire now has 65536 elements, 128 loops with 128 elements per loop. And this is the binary lattice plotted. So the blue area has values 0 because they haven't been visited yet. And all of these black and white squares on that are the -1 and +1s. And when you rotate that and you look at it as a two-dimensional projection, i.e. think of it as a three-dimensional hand projecting onto a two-dimensional surface, you can see that there's a Mobius strip here. And that is what describes the 720 degrees of rotation for the helicity of the electron, because obviously the ant is not an ant, it is in a charged particle. And this is the one-dimensional array of this. And so the grey scale here, these little white spots are this, and where you can see the 104 highway there, this is the 104 highway. It's here. And this gap here is this gap. Because remember, this is a surface. So this corner and this corner and this corner and that one are all connected into a toroidal shape. Thank you very much for listening.